Run this. This webinar is going to be more or less in the same format as the very first webinar. I'm going to give a bit of a short speech first, and then we'll go into a tutorial. So, welcome to the 6th webinar from eFabless. Thank you all for joining and listening to this presentation. In this webinar, I will present the eFabless tools for circuit layout, which we are finally launching after much effort and also after a bit of interruption from the first part of the challenge. All of us here at eFabless think that the first part of the challenge went rather well, with a few bumps along the way as we worked out some of the kinks in the process. The eFabless Design Challenge was something new, something that has not been done before, something not been tried before, something for which we ended up having to invent certain procedures as we went along. We've been busy for the past several months, not just with running the first part of the challenge, but also with putting together the layout tools and making sure that they work with other parts of the platform. The layout development has been going on behind the scenes from the perspective of anyone working on the eFabless platform. The layout support on our platform contains a lot of new software, like the automatic characterization tool was new software that we developed for schematic design and for enabling the challenges. And we have also written a Foundry design kit that is entirely developed by us for the open source toolchain. Those of you who are familiar with Foundries and layout software will know that this is not a trivial task. Some of you are right now in the middle of working on the XFAB challenge, and this webinar is the first introduction on how to move forward from the schematic design into the layout portion of the challenge, and no doubt you're impatient to get moving ahead with it. The layout tools were just released onto our production platform yesterday. There are some existing video tutorials and other information that you can find on the eFabless knowledge base on the website. In particular, there's a nice set of 3 video tutorials by Bertrand Irisu that contain a lot of general use information about how to use the layout tools, and it complements what I'll be going over in this webinar. We specifically designed our first challenge in 2 parts, one for schematic design and one for layout. We did this for several reasons. For one, we wanted to create a process of breaking an overall project into discrete parts. This provides the challenge sponsor, that is XFAB in this case, visibility on the overall progress of the challenge, and it minimizes the time commitments for those participants who will not make it through to the end. Over time, this will allow us to facilitate collaboration where community members may focus on their specialties and leave other parts of the challenge to others. Second, we wanted to give ourselves extra time to put the finishing touches on the design kit we were developing for the platform for the XFAB XH035 process. As I mentioned, this is not a trivial task. We also had to work out the problems of how to present layout design tools in a public environment where people would be able to do layout design without having an NDA with the Foundry and possibly other IP vendors. The problem here is that foundries are understandably very protective of their own proprietary information. We wanted to avoid the problem of allowing too much access, which then requires that every participant must sign an NDA with the foundry and possibly other IP vendors as well. This is fundamental to our model of value to you. Our compromise is probably going to feel constraining to designers who have done layout before and are used to having complete control over every aspect of the layout. Please realize that we are trying to do what we can to make this compromise work out to the best. Much of the tutorial part of this webinar will be to show you what you can and cannot do with the layout. Much of our help request response through the second part of the challenge, I expect, is going to be figuring out how we can make the layout tools more flexible to the user while maintaining that compromise. We are a small company and privately funded, and it has been important from the beginning to get our platform up, running, tested, and out to the public in as little time as we can manage to do it. To some extent, we will be relying on the community to help tell us where we need to improve or to fix our tools to make using the eFabless platform a better experience for everyone. We hope that we have shown during the first part of the challenge that we are responsive to requests and that we do our best to accommodate the needs of our users. I've always found that companies that excel at customer support are the most loved by their clients, and I want to do my best to make sure that eFabless is one of those companies. I'd like to spend just a minute on the topic of the challenge finalists and runners-up, and those who didn't make it to submission, and those who made it to submission but didn't quite manage to hit all the specs. I do understand and appreciate the problems of working hard to meet the specs and not making the cut because we have a prize structure awarding a limited number of prizes. Please bear in mind that every decision on how to structure the challenge was hard. We're working in uncharted territory here, trying to figure out what works best for the community. We had no idea going into the challenge whether or not we were going to have anyone meet the spec, let alone 1 or 3 or many submissions or what. It turned out that we had a bit under 100 people accepting the challenge, of which around a dozen or so were able to get competitive designs worked out and submitted, if not necessarily completed, by the deadline. Of those, 6 designs met all of the XFAB specs. Between software development, bug fixes, and help requests, that ended up being about as much as we could handle in the time allotted for this challenge. As the finalists for the challenge go into the second stage of doing layout, I would like to stress above all that the layout tools are here for everyone to use, not just the challenge finalists. And I would like to further stress that we do have very short-term plans for putting up our marketplace on the eFabless website, and additional ways for people to get their own designs out to the public, to collaborate and to share their intellectual property and their talent, and to be recognized for that talent. As for the marketplace itself, it will start out relatively empty, except for some IP that XFAB is generously allowing us to put there. We will need to fill it up with good designs, and we need to keep it growing with more designs and more categories. This challenge ends with a few circuits that will meet XFAB's bandgap requirements as they set them out for the challenge, but there are other designs that have been submitted that may not have been among the finalists, but are good contenders for the marketplace. The first eFabless challenge, of course, was geared toward the single superlative of the circuit, the bandgap circuit with the lowest power. However, the marketplace will have room for all circuits that pass our certification, and over time, this will be circuits with the lowest area, the circuits with novel architectures, the lowest noise, the best power supply rejection, and so forth. It's impossible to know exactly what will be the needs of somebody who comes to the eFabless marketplace looking for a circuit to meet their needs and solve their problems. So with that said, I invite everyone who got through the challenge with a working circuit in hand to look into our layout tools and to learn to use them, partly for the experience and partly to get that circuit finished. And if it's good, perhaps it can be up on the marketplace for people to see. If you didn't have a working circuit in hand or didn't participate in the challenge for whatever reason, it's still a great time to get started learning the layout tools and to be prepared for the next challenge, or whichever one you feel is a good fit for your talents, or just so you can design your own circuits and get them up into our marketplace. If you aren't one of the finalists for this challenge, there will be more challenges, which we plan to continue right away, with the next one being right on the heels of the first, if not before the first challenge ends. The structure of each challenge will likely be different and will be evolving over time. If the first challenge wasn't up your alley, so to speak, it's certainly not up mine, I'm not a bandgap designer, then maybe the next challenge will be. So after that introduction, I'd like to move ahead to more of a tutorial and a less scripted and a more ad-libbed presentation. I intend to cover information about how to automatically generate an initial layout from the schematic netlist, and then how to use the layout tool to put everything together. This includes how to tell if a design passes design rule checks. What I'm not going to cover is the process of comparing the layout against the schematic, that's known as LVS, and extracting a netlist with parasitic components from the layout final submission. We only have time for so much in one webinar, and that part will wait until next week for the next webinar. Most of this tutorial will be to introduce you to our layout tool, Magic. Some of you are probably aware that I have been the primary developer of Magic for approximately the past 20 years and have managed to keep it viable enough that companies have been able to use it and continue to use it for getting real products out the door. As I mentioned before, the compromise of allowing the construction of layout while protecting Foundry IP is a problem that we have addressed by limiting the extent to which layout can be manipulated by the designer. The design experience on Magic, and specifically on Magic on the eFabless platform, will be a bit different and will likely take some getting used to. We'll be looking for feedback on this experience as people start using the tools in their present form and we move on to the end of the first eFabless challenge. Always feel free to contact us about your needs, concerns, or just your opinions on how it all works for you. So, as I said, that ends the scripted portion of this. I'm now going to share my screen so you can see what I'm doing as I go through this tutorial. The first part is going to be to start where everybody starts, logging in to the Open Galaxy server, to the toolbox and into what we call Open Galaxy. And by the way, if I ever stop dead in the middle of one of these tutorials, it's because I'm trying to consult my notes as to what to cover next, so I can make sure that I'm doing this in a proper manner where I cover not only everything, but also in an order that makes it easy to understand. So the first part, of course, is here's the project manager, which we've had up for the first part of the schematic. Now, if you've done the first part of the challenge, then you'll know that there goes along with it this data sheet. And if I don't know if you've noticed this before, but at the bottom of the data sheet, we have not only just the electrical parameters listed, but also physical parameters. And the physical parameters include the area, the width, and the height of the cell as required maximums by XFAB. Now, the problem is, as we went into the first part of the challenge, we didn't have layout tools, and so there was not a value put on any of these things. If for all of the data sheets that you may have seen as it got put up on the website, this block was always empty because we have no way of specifying an area, width, and height of something without layout tools to measure it. Likewise, when you were in the characterization tool, let me go to the challenge design here. When you're in the characterization tool, it would tell you nothing about area and width and length and so forth. Now that the layout tools are up, you're going to get a slightly different view of this characterization window. So this part of it looks the same. However, if I go down to the bottom, you will see that now, in addition to all the parts where you can simulate to get electrical parameters, you also have now checks for area, width, height, DRC errors, and LVS errors. I will get around to covering LVS errors next week when I do the webinar on LVS. For now, right now, I do not have a layout for this. This can be checked if I am in the, come on now. If I'm in the directory for the layout, which is called .mag for magic, if there is layout, you will see a whole bunch of files with .mag extensions. Those are the layout files for the project. Right now, there's nothing in it. There is no layout. If at this point I go to the characterization tool and check one of these, it is going to do a layout estimate. I do encourage you to go do this check on your circuit before you get started on layout. If you've already gotten started on layout, it's not terribly important, but it is a good check. It is a good first pass check of how big your circuit is likely to be. It does involve a fudge factor. So here, I'm going to go click on check. It is actually creating layout on the fly. The process of estimating the layout area is to take your schematic netlist, parse it for all of the designs, for all of the devices in that design, then go to the layout tool, generate each of those devices, and compute the total area of all those devices, then multiply it by a fudge factor, and that gives you an estimate of the layout area. So in this case, I'm using this design here that's something that I made a while back. That it's a really poor bandgap design, but it works well for the purposes of demonstration. It also, according to the estimate, fits easily in the area. You can also do width and height checks, which is simply it's going to be the area. The width area is the total estimated area divided by the height. The estimated height is the total area divided by the width. Without a layout, there's absolutely no way to do a DRC check. If before you have layout, you run check on DRC, it simply disappears and says not checked. It will continue to say not checked. So the first thing to do is to get yourself a layout, and assuming that you have you're doing this in the context of a challenge where we have a characterization and you have the characterization window. The one important thing to know is that you will need to do at least one simulation in order to have a valid netlist on which this will run. That valid netlist has to be in place before it can do all these estimates, for instance. So if you run this and it fails, you can just run one of these simulations. That will give you the correct netlist output, and then you can run these. Likewise, the netlist is what it uses to create the initial layout. So back over here in the project manager, I'm going to click on Edit Layout. And again, because there is no layout existing, it will tell me immediately in a pop-up window, there is no layout for project. And I get a checkbox saying Populate New Layout from Netlist, which, generally speaking, that's what you're going to want to do. So I'm going to click on OK. And here is the first view of our layout editor called Magic. Before I get into too much detail about what just popped up inside it, I should give you a, if you are calling in and are not on mute, can you please put your Zoom session on mute? So this is the layout tool. And we have across the top a set of menu buttons that can be used to manipulate various different commands. Part of this is layout manipulation, such as for cells, edit for layers, just for getting yourself around the window. There is some options for looking at DRC errors and so forth. Continuing along the top, there's a live view of how many DRC errors you have in your netlist. As soon as it created the first initial netlist, it already ran DRC, and that's the number of errors I have. There's a little information about what cell you're editing and what tool you're using. I'll get into that. View of what the position of the cursor is in the window. Down the side, these are all the layers that you're allowed to edit. You'll notice that it is a very short list. This is the compromise that I was talking about, in which you are generally not allowed to mess around with diffusion and poly layers except through predefined manipulations of the gen cells. I may call them P cells, which is a cadence term, but those are the predefined layouts that we have for each cell. I'll show those in just a minute. Continuing on, we've got the scroll bars for moving around the window. You can also move around using the keypad. I'm not sure how well the keypad works for every user through the VNC. I've heard that there are some problems with that. If you can't use the keypad, then you can get around with the scroll bars. And then there is a window at the bottom for looking at layout. It has a sash on top of it if you want to expand that view so that you can see more of the output that Magic is providing back to you. Now going back to this layout, start telling you about, well, first off, the fact that I actually have a layout now. This layout was not just generated up in the layout tool, but is actually on disk. So if I go back and look at the directory, that you can see there are now all these cells, files that have been created for the layout. So the layout is there. If at this point I go back to the characterization tool and run these checks, I'm going to get the actual layout instead of an estimate, because the layout exists. You'll also note that when this automatic layout generation runs, it just goes through and puts each cell that it finds in one long line. It definitely is doing no optimization, no kind of placement algorithm or anything like that. You're just getting each of the devices that's in your schematic end up in your layout. This is a very inefficient design here with a lot of wasted space, and you're going to see that immediately as I do this check for area. And yes, this check for area is way over the limit because it's wasting a lot of space. So that's to be expected. So obviously, the first thing you're going to do once you've brought up a layout is try to floor plan it in a way that will get it down to the size that you need. I'm going to start that process by, well, first I'm going to go through a few things that you'll need to get around Magic in the most basic sense. As I said, there are those 3 layout tutorials up on our knowledge base site, and you can use those if you want to have additional information or want to go over some more of the details. So first off, the view of the position, the second set of numbers here is always the position of the cursor relative to the lower left corner of the box. So I know that my design is supposed to fit in a 200 by 300 space. So here I can bring that down to, here we go, this is 300 across and 200 down, approximately there. Now I'm going to go paint, and here I'm going to have to introduce the concept of the cursor box, which is very fundamental to Magic, that if you want to paint layers, you're going to have to define the cursor box. The way the cursor box is defined is that the lower left corner is set by pressing the left mouse button, and the upper right corner is formed by pressing the right mouse button. So let me go back to that 200 by 300 area that I wanted, which is about there. Okay. And if I want to fill that box with something, so here I'm going to fill it with metal 1. I'm going to go over to my tools and click the middle mouse button to generate the layer, and that fills the box. Magic's idea is of painting on a plane, so they refer to it as painting. It is, it's not object-oriented, so I have not just created 2 rectangular objects, which is what it would be if you were in most layout editors, including something like Cadence, is that each rectangle you drew would be a separate object and separately selectable. In this case, I have to treat the layers that I paint as having painted into a mask. It matches the idea of the mask layers as they go to production. You've created these black and white designs on each mask layer to represent your layers. Now, some things in Magic are done relative to the mouse pointer, which I'm going to call the pointer, and other things are done with respect to that cursor box. I've just showed you how you paint a layer into the cursor box. If you want to select a cell, you're going to use the pointer. And the command for selecting a cell, again, because this doesn't do real-time selection like Cadence does, nothing will be selected until you specifically select it. So we have a key binding Control-I for selecting an instance. So Control-I for instance. I can put my cursor over here and hit Control-I. And discover that it doesn't work for some reason. Nothing like glitches and Control-I, Shift-I, I. Have I done something like, I have lost my keyboard. Let me try this. Okay, that is very unexpected. It is going to be very hard to get around without having keyboard control. I will... let's see how much I can do from the command. There are 3 ways to get around if you don't have key controls. There are 3 ways to do commands in Magic. One is the key macros. The second is to type in commands on the command line. And the third is to use the menu options that we have. So if I want to select something, I can say select area. Oh, you know what? I know what it is. I think I know what this is, that Magic sometimes puts windows up in the background. No, it's not. I am very confused here. Okay, I'm going to try to get through this without having keyboard entry.
Tim, do you want to try the production site?
Yeah, I'm thinking that might be a good idea. Well, let me give staging site a try first. Let's see.
Okay.
That's not one that I want, but yeah, okay, all right. I'm just going to switch to the staging site. I'm not sure why I lost the track of that. Yeah, thank you for that suggestion. I did not need to be wandering around there. But for that, I will need to briefly go down and remove all of that and go back to creating the layout. All right, here we are. So, yes, Control-I selects a cell. Now I'm back to where I was. So I put the cursor down, I select Control-I, I can select the cell. I can also do an area select from this view with the A key, area select. To expand the view, I would go select the cell S. We'll select a cell if it's unexpanded. Capital F, this is a cadence binding, will expand the view. Now here's the thing, when the cell was unexpanded, which I can do with Alt F, or Shift F. Okay, not. So if I have an unexpanded cell, I can select it using the S key, which is usually used to select paint, but it will also select unexpanded cells. Within a cell that is expanded, if I use the S key to select, what I will get is just a selection of the paint inside the cell. So here I did select, it gave me the area of the gate for this device. The reason it does that is because it allows you to do a multiple selection using the S key over and over to do not just to select paint, but also to select an entire net. So for instance, if I go over, put the cursor pointer over top this guard ring contact and press S, it will select the contact. If I press S again, it will select the whole connected network. In fact, here it's shown that the well underneath this device is connected to the well under this device and has gone ahead and selected the entire network as it's connected through the well. So that's a fairly powerful feature of Magic, that you can connect through networks like that. Having just created this, I'm going to go, if I want to save it, I can hit save. Once it's created these devices, and once you have expanded them, it runs a DRC check on everything, so it's going to want to save all of those. You can type auto write, it will save everything, and then you can quit. And then once you have that layout, anytime you go over to edit layout, it'll bring it back. So now on to what you can and cannot do in Magic. In this case, there are each of these devices is called a gen cell. It comes from this menu here, devices. If you want to, obviously this one was created automatically from the schematic, but if you want to create a new device for yourself, you just go to the device, and this is very much like a parameters view in Cadence. When you want a new device, you will get a list of the parameters, such as width. Okay, I want to make it a width of 2. I want to have, say, 2 fingers, an M of 2. Before I hit create, I want to go over here and place that cursor box where I want the device. Look, bring that back up again. And it needs resizing. Okay, so do that again. Width of 2, 2 fingers, m equals 2, and create. And that creates the device down here. You can see it's got the properties I asked for. It's got 2 fingers, m equals 2. That's the vertical arraying. There are further things that I can do, but I cannot edit these layers. So what I've done, or what I've tried to do in the design kit, is make this as flexible as it can be to try to give the user the ability to change as much as possible on the diffusion and poly layers, even though you don't have direct control. You have indirect control through all of these parameters. For instance, if I don't want the gate connected between the top and bottom, I can click on Add Top Gate and Apply, and the top gate disappears. Or the bottom gate, and I can have all of them. If I want all of these things connected, I can just connect them together. Again, use the middle mouse button for paint. Use the select 3 times to select the net, and I've connected all the gates together. D key is for delete. Again, Control I selects the device. Q, if this parameter window is not up, Q brings up the parameter window, and from the parameter window you can make all sorts of changes to the device. For the purposes of the challenge, though, these are the devices you're given, and they are supposed to match the schematic. So if you add extra devices, you're no longer going to be matching the schematic. However, now getting into the idea of floor planning, most of you who did the challenge for the band gap, of course, it was a low power band gap. One of the things that most low power band gaps are going to have is very large resistors. And as you can see, that's the very large resistor that makes this a very inefficient layout to start off with. And the best thing to do if you want a reasonable layout would be to make this device into something with a much better aspect ratio. In fact, this is, like most band gaps, is dependent on a ratioed set of resistors. So this particular one is 14 times the size of this one. This one is 14 times the size of this one. So the total number of resistor sections that I really want is 15 plus 15, or 30 total. However, the schematic tools don't have a way to specify a single device as being, or a single resistor device as being divided up into a number of series devices. So I'm going to have to do that within the layout. So I select this, again, Control I. Actually, I'm going to select this one because it's the unit resistor I want. Use M to move it over here. Move up a little bit in the layout. Okay, and then Q brings up the parameter window. All right, now to get rid of these devices, I don't want these 2 long devices. I want this one arrayed 30 times. I'm going to do a repeat in X of 15 and a repeat in Y of 2. Hit Apply. Now, these things are not connected. What I've said is I just want an array of 15 by 2 resistors. I've not specified that this one is a dummy resistor, this one is an unconnected resistor, and all these are in series. So I'm going to have to go through in the final layout and connect these because they are, at this point, unconnected resistors. However, what it does do is give me the right aspect ratio for that whole set of resistors, and now I can go delete these resistors that I don't need anymore because they're taken care of in that block. Likewise, I can do the same thing for this one. For these are some series resistors that I had 4 in parallel, 2 in parallel, 2 in series, 2 in parallel. So there are 4, 5, 6, 7, 8, 9, 10, 11 of these single resistors here. Again, I can tell it, all right, I'm going to do an X repeat. And then I can get rid of all the other resistors, and I'll need to make sure that I connect these 4 in parallel to match this device, these 2 in parallel to match this device, so forth. One thing I said that this gives an area estimate based on single devices when you don't have a layout and you run the check, and it gives you an area estimate. One thing about that area estimate, it was giving the area for single devices such as those very long resistors. Well, the very long resistors, as you can tell from any of the single resistor devices, the area of the general purpose cell itself is actually dominated by the guard ring around the resistor. The actual resistor is this layer right here. And you can tell that the whole cell is actually about twice or more the area of just the resistor. So when you get that area of the single device, you're getting actually something that's somewhat pessimistic for total area once you have optimized it, not just for the aspect ratio of the device or the compactness of the resistors, you've also reduced the total area of the devices. So from here, the main floor planning is just to go through and figure out where all your devices are and where you want them to be. You'll want to do things like put your resistors together, put your P devices together, put your N devices together, make sure you have room to put power buses throughout the circuit. Again, I have these 12 PNP devices, which will be better off if they are arrayed as, instead of 12 individual devices, make an array of 4 by 3, like that. Move it out of the way. So I'm not going to spend the time in this webinar to go floor plan my entire band gap here, but you get the general idea of moving things around, trying to change the aspect ratio of devices that are obviously not right for the layout. Another thing for optimizing the area is that, again, we put the guard ring on. The reason that every single device is surrounded by a guard ring is largely so that we do not have to take care of all the design rules, so we're not exposing the design rules on the poly and diffusion layers. Because pretty much if you don't match up the guard rings of cells, then you're going to violate the design rules for the guard rings, and that's sufficient to make sure that the entire cell is DRC clean. If I take, for instance, this cell and move it until it's overlaying that cell, then you'll see that there's everywhere you see these white dots appear, that's a DRC error. If you check the DRC listing here, I have DRC 70. That's my DRC count of violations. If I move that cell over, then actually I have no idea why the DRC count went down there. There must have been more DRC errors over on the other side that I wasn't looking at. But yeah, you'll see the DRC count change when you do an overlap like that. The way the cells are designed, the best way to get the things to be optimally spaced is to overlap these guard rings. So I'll take this cell and move it over. Whenever these contacts don't align, the problem with having contacts in different subcells is that the contact cuts would not align, and that would be a DRC violation. So if you have contact areas like that, as long as you can overlap them exactly. Now these two devices are sharing the guard ring, and so that's the most compact layout that I can make with this. Ideally, I will want to put as many of my P devices all together so that they're sharing the same guard ring area on all the N devices so that they're sharing all the guard ring area. Because contacts have to overlap exactly, if I have something like this where the cell width is different than it is over here, then if I try to do the same trick there where I overlap the guard ring, then I can line it up at the bottom, but I still have a DRC error. Why? Because this guard ring contact does not match this guard ring contact, and there leaves the possibility that the contact cuts don't align and would create a DRC error in the final mask. For that, I will go over here, select this cell, and I have the ability to say I do not want to add the right guard contact. And when that applies, this guard ring is gone. So if I select this, move it over, you can see no more guard ring contact on that side. And so now that section is DRC clean. So if I can do that for as many of the NMOS devices as I can, put them in a row, they will line up very compactly with the guard rings overlapping. Likewise, for the P devices, put them so that the guard rings are overlapping. One more important thing about the cells that you get when you do the automatic layout, automatic conversion to layout from schematic is that whatever is a pin in your schematic is going to appear as what is called a port in Magic. If I select that port, I can go over here to Edit and Text, and it will show me that, yes, here's the label that I just selected. It is a port. The number here is the order of which that port will appear when it creates the SPICE subcircuit when you generated Netlist. So this one is port 0. These are in order. So this is port 0. Down here we have port 1, port 2, so forth. If I want to create a new port, for some reason, I would paint a bit of metal. I would go over to the middle of it, declare the area that I want that port to appear in, type A to select all, go over, select the text. Now it's telling me I have a new label. If I want it to be a port, it's telling me here that the port number is going to be 9. That's going to be at the end of all the other ports. I can say test port and apply, and I get a new port. This is to be distinguished from plain labels. So if I again go make myself some metal, go over here, select the area, bring up the text again. Now if I say I don't want it to be a port, then it just becomes a plain label. I'm going to call it test label. And you'll see it comes up in yellow. The difference between the yellow label and the blue port is that this port becomes meaningful for the subcircuit. It becomes a pin of the subcircuit. This will not. This will not show up in the subcircuit. And since the LVS tool that we're using is going to compare the top level circuit of your schematic versus the top level circuit of the layout, then you will want just the ports and exactly the ports that are given to you here. So you can delete them and recreate them as you want. I sort of suggest that you go ahead and make the wires that you need to put them on. For instance, okay, I want a VSS bus and I want a VBA bus. So I'm going to go select the port and move it. I'm going to select the VSSA port, move it. Okay, now I have a big power bus for VSSA. I have a big power bus for VBA. So with about 15 minutes left here, I'm going to quickly go through, well, I was going to go through a different layout. Let me see if I can bring this back long enough to work. Apparently I'm not going to have key control in here, but I do have this design that was made by Jay. This shows something that I wasn't showing in the other one, which is what happens when you have hierarchy in your schematic. So again, there's no layout associated with it now. I'm going to create my layout here. Before I show you what just came up in the layout, let me take a quick look at the schematic for this one, which is a, well, let's see, the top level schematic is up here. All right, let me just bring that up. Okay, this is the top level schematic, and it contains two subcircuits. It's just a simple differential pair with the differential pair set here and the tail current bias right here. Very simple circuit. The differential upper then looks like this with 4 transistors, and the total circuit instantiates each of those subcells. So that subcell structure comes out directly in the layout. You can see here's the differential upper, here's the differential lower, the tail current. And I've got keys back again. I don't know what happened there. All right, so I'll continue to work with this. So here I can, if I want to edit this, I will need to, just like in the schematic viewer, I need to descend the hierarchy. And for that, I can go down to Cell, Down Hierarchy. Now I'm editing just that part of the design. So I'm going to take my pins, move them out of the way, take my end devices, move them under, move them down until I don't get a DRC error. You see there are DRC errors here where the guard rings are too close to each other. However, I would point out here, and this will, since there are typically op amps in the band gaps and differential pairs, the fact is that in the schematic, the differential pair is going to be two separate devices. And because in the schematic they're two separate devices, they come out in the layout. Nope, that's not the layout. They come out in the layout as two separate devices as well. But it's a differential pair, so in the layout it will naturally work better if it's a single device. So I will for that. Select, losing. I wonder if I get rid of that. No. All right, I've lost key control. Something about bringing up the schematic editor is causing the key control to get lost. So let me go back to this one to illustrate what I wanted to do, which is if you have a differential pair, and there are several in this design here, now I have lost key control in this one too. Okay, that seemed to work. All right, for some reason going from one window to another changes the ability to get key controls. All right, anyway, here we are. In this one, I take the instance, I can change this instance into a two-finger device and apply, and then get rid of this instance. So that will make this a better device for a differential pair because it's better to have fingered devices than to have individual devices, though you can do it either way if you want. And again, delete that one, and then do the same thing. Since this is a current mirror pair, do the same thing. Go bring up the generic cell view, change it to two fingers, and then go over here and delete the first one. So just to note that because you have something as individual devices in the schematic doesn't necessarily mean that you have to keep them as individual devices in the layout. And likewise, for the long resistors that I was showing, just because you have something that's a single device in the schematic doesn't mean that it can't be multiple devices in the layout. The LVS tool will take care of all that. It will match them correctly, no matter how they're split between the schematic and the layout. To go back up hierarchy now, now I have, since I changed that layout, I'm no longer, I'm now creating a DRC error with that, so there's the whole, that's one thing to mention is that if you do a Control-I to select, Magic will tend to select the lowest level cell, even if it's not editable as such. So when I did a first selection, it picked up the NMOS inside the cell, but I can't, if I type M for move, I can't move it because I can't move that within its own cell. If I type Control-I twice, I get the whole circuit, and since that subcircuit is within the edit cell that I'm doing, I can move the whole subcircuit. So again, with the hierarchy here, I can move this around with the keypad until I match up those devices, and now I'm DRC error free. So that's how you manipulate the layout of a hierarchical structure. If you had hierarchy in your schematic, it will end up in your layout. There is, I think, one more thing I want to cover. Oh, wiring. So if you want to wire things up, the best thing to do is to use the wiring tool. If you type the space bar, it will go, this is, I said, the tool, what we have here is the box tool, which means that if I use the mouse buttons left and right, it manipulates that cursor box. If I click the space bar, I go to the, let me try this again, spacebar. No, it will not let me use that tool again. And I've lost the key. Oh, here we go. I'm going to type that in by command, tool wire. And it didn't do it, tool wire. Okay, let me see if I can bring that up here. Okay, yes, here we go. Tool wire. So if I hit the space bar, now I've gone from the box tool to the wiring tool. The wiring tool now no longer manipulates this cursor box, but if I do a left click on a piece of metal, it will select whatever area of metal is behind it, and I can use that to extend out a wire. So I just selected the metal one here on the VSSA. I can extend that out. If I left click again with the mouse, I get a wire. So I can use that to create a wire however I want. Now you can use the wire tool to go move between layers. However, the problem with that is that the contacts require certain surround rules. Another way to draw contacts, which I also don't recommend, is that you can just go up here, click on the metal contact layer, and when I do that, you'll see that I immediately get DRC errors because it's missing the surround rule. If you want to find out why that DRC error happened, you can always go down to DRC and say DRC report, and it tells me, okay, metal 1 overlap of via 1 is an error. I don't have metal 1. Well, the easier way to do this is just to, I didn't mention that, is that while you can create layers by clicking the middle mouse button on here to fill in the box, you can also delete everything in the box simply by clicking the middle mouse button on the background. So I'm clicking the middle mouse button here with my pointer on the background, and it's gone. So here inside the cursor box, I can go over to devices and via 1, and it draws me a via that has all the metal surround already done. So I think that's the best way to work with a wire. Then if you want to continue the wire, you can align yourself up to here, and then with the middle mouse button, paint metal 2, spacebar, go back to the wiring tool, and the wiring tool continue here. For purposes of wiring, aligning things is very useful. So I have the option of going to the crosshair, and that gives me a little crosshair that I can use. So if I want this metal 2 line to go all the way up to metal 1, I'll just click on this to start the wire and make sure my crosshair is lined up at the top. Of other useful features of Magic, I would say probably the main one, particularly if you're using a hierarchical design, is to keep the cell manager up. The cell manager allows me to go look at what all the devices are. I can expand this tree view and see all the devices inside. So if I want to find, okay, where is RW6? I can click on RW6 and zoom, and it will take me, okay, here's RW6. So that's probably the easiest way. As you're going through, you're going to want to bring up your schematic and say, okay, how is this device connected? if this device, the devices are going to be named as they are, you recognize this as a electric default naming, but in electric, it would have been called XRW underscore RW at 8. And you can find that in this list and go find it. If you want to expand it, click on expand. Now you got the expanded view, and then you can start wiring that up. So this is very helpful to cross-reference between the layout view and the schematic view. And finally, I think the last thing I wanted to mention, as we are getting within a few minutes of the end of the hour, is the substrate ring. I did say that you are, in this design kit, not allowed to use the substrate or diffusion or poly layers. They're not something that you're supposed to be editing. However, there is one exception to that. Let me go back to this one. There's one exception to that, which is the diffusion layer. And so if you want to create a well-connected substrate, you want to use here subdiff. It's not quite the same as the subdiff that exists in here, but it is, I think, is it compatible with it? I think that does, yeah, okay. So you can connect up using this subdiff layer. You are allowed to paint with this layer, and you can connect up to the substrate layers in other cells. Normally, you'll probably want to do the contact instead of just the diffusion layer, and then connect up to your VSSA bus, say, with by drawing the metal lines. So I think that covers pretty much everything you need to know in order to get started with the layout. And so at this point, I'll open it up to any kinds of questions you might have. So go ahead.
Hello.
Yes.
Hi, Tim.
How are you doing?
I'm fine, thank you. This is Ibrahim.
Mm-hmm.
I realized that there are something called magnet and fence and rotate, which I didn't understand. I think they are layers, listed layers at the end on the right, on the very right side of the layout box. And you see these there are 3 layers that I don't understand what they mean.
Yes, I had put in the PDK something that would cause them to disappear, and I'm not sure why they're appearing in this case. My advice is, if you see them, ignore them. They are specifically to do with Magic's internal maze router algorithm.
Okay.
They're basically layers that you put down as hints for the maze router, and I don't really suggest using the maze router. It's not exactly the world's most optimal router. Like anything in Magic, you can always play around with anything that Magic has the capability to do, and that includes the...
And also, I want to...
Go ahead. Mm-hmm.
I want to understand the M1 hole and M1 contact. Those are used to make a veil, right? Or
No. Well, the M1 contact is, well, the M2 contact. So if I put a box here and go over here and fill it in with M2 contact, this is another important Magic concept, is that its idea of contacts is more, I don't know how familiar you are with the LEF format, but LEF defines something called a via generate rule, so that you say, okay, I have this area and I want to generate cuts within it. So this is sort of like that, and that what you've defined is an area into which there will be cuts. So when it goes to generate the final GDS mask layers, it will fill this up with cuts. So this, given the size of this, it's probably going to have like 5 by 7 or so cuts. Again, in order to prevent seeing all the different low-level rules that XFAB or the Foundry wants to keep proprietary, we leave it at this view. You're not allowed to see the cuts. You can sort of guess from the size of it at how many cuts they're going to be. This will be, as I said, probably like a 5 by 7 array of cuts. The whole is just for large metal width buses, such as if you make something that is, like 30 micron, I'm not going to draw a 30 micron line, but you can paint down a hole and it will just create a hole in the middle of that. So that's not metal. That's a hole, but it's their special DRC rules having to do with holes that make them different from metal layers. I generally don't use them. To me, it's pretty much equivalent if you just leave it as an open space.
So M1 contact is of like a via, or it is not.
It's M2 contact, but yes, it's like a via, but think of it as an area into which vias are placed.
Yes, I got it. Okay, so another thing I wanted to ask is how to stretch a rectangle. I mean, in some other tools or some other tools, yes, I have been using. I could actually choose some select some side of a rectangle and then stretch a rectangle. Can we do that in this tool?
Yeah, this is Magic's way of doing it is a little different. Again, as I said, Magic has this idea of paint instead of objects. So you're not taking an object and changing it. You're actually
there's no vertices or things like that you can select.
That's right. That's right. So I wouldn't be able to pick up this little vertex and move it. But what I can do is to say use the A key to do an area select. All right, now I've selected that area. And there's a key binding I'm not used to, but I think it's like Control. Yeah, that was Move. Okay, for instance, Control with the arrow key, that moves it. Let's see, what is it? Shift with the arrow key. Okay, Shift with the arrow key is stretching it. So if I want to stretch it over, just do that. There's also the stretch command. There's also a fill command. So if you want to type in things by the command line, one thing I can do here is say stretch east 10 microns. Oops. You also have to be able to spell. But, try that again. Stretch east 10 microns. And that was just, yeah. Oh, there. So I just selected it, stretch east 10 microns, there. Also fill, for instance, if I have the cursor box set to this, I can now say fill. If I don't hit the wrong key, I can say fill east metal 1, and it fills it to the end of the cursor box.
Do you have a manual that explains these kind of commands?
I think some of that is covered in Bertrand's 3 tutorials on Magic, and for the others, you can go to my website, Open Circuit Design, and click on Magic and click on Using Magic, and there is a full set of commands and explanations. There's also help, but that doesn't, I can say help fill, but that doesn't help me if I don't know what the fill command is to begin with.
So from your explanation, we can't do our own devices, right? We have just to use the existing devices, right?
That's right. But that said, I do want to say that if you have a specific need for a device, that I'm willing to do what I can to try to fit that into the PDK. Obviously, it takes some time for me to develop things like that. But for instance, having noted that there are some designs out there that have very, very long resistors on the order of mega ohms. Your circuit might be one of those.
Yes.
That the device for the, say, whatever it is, RP1 resistor,
yes,
is maybe particularly large and very difficult to make something that is that size. And what works better in those cases is a snaked resistor.
Yes.
So I will probably, I promise I will be doing this, try to work up a snake resistor type resistor in the PDK to facilitate that.
Okay, so is there any feature that makes me to show just one layer if I want to show just one layer, one specific layer? I mean, showing on the layout, I want to see how the middle one looks like at the whole layout. I don't want to see the other layers. Can I do that?
Yep, you can go through, the manual way is to go through this toolbar and to right-click all the layers you don't want to see.
So that's, yeah, I got it. You're hiding all the layers and just leave the layer that you want to see, right?
Right, although there's also a command there which is see no star, and then you can go see metal 1, which is probably more appropriate in this case because that gets rid of everything. Since the diffusion layers are not listed over here, then you can't.
Yes, yeah, got it.
Seen,
another question here. Can I draw a rectangle with a specific dimensions? I mean, if I want to draw some rectangle with specific dimensions, I want to enter the width and the length of this rectangle. Can it do that?
Box width, 10 microns, 8 microns.
I got it. Okay.
I'm sorry. There wasn't. There wasn't a box. Okay. Sorry. Box size. Right. There we go. Box size. 10 microns. 8 microns.
Yes.
And then fill it.
That's great. Another question. Can I draw some boundary? I mean, if I know that the area boundaries are 200 by 300, for example, so I want to draw some text layer or some rectangle that doesn't mean anything to the DRC, but just showing me the boundary of my layout. How can I do that? Do we have a text layer? Can we draw a rectangle of a text layer?
It occurs to me that I don't have any comment. There's usually a layer called comment, and it is not in the PDK as a user-definable layer. I think that's a mistake, and I will take that as a help request there. That makes a lot of sense to be able to have comment. It usually comes up as a black layer. So, yeah, I'll do that. That makes a lot of sense to be able to put a comment layer so that you can draw in your bounding box around your...
Yes, you're right. And devices, you said that devices are not editable, right? The instantiated devices has to be used the same way it is, right?
Well, no. I mean, what I was doing was, to the extent that you can change them with the parameters here, and that includes the difference between with different contact coverages or adding or deleting contacts. Whatever you can do in here is what you can do to that device. And beyond that, if you have something that you feel is really necessary, then again, like the snake resistors, come to me and say, can this be put in the PDK? And in the worst case, I'll say, no, that's sort of fundamentally impossible to do. And in the best case, I'll say, sure, yeah, that's trivial. And in the middle is the one where it says, give me a few days to work on it and I'll get something for you.
Okay, another question. Sorry for those long series of questions.
No, not at all.
Okay, so I want to know also how to make a cell out of some selected devices. I mean, if I can select some devices and I want to create a cell out of those devices.
For instance, here I would go take everything and hit Control F in order to make sure I have unexpanded all the subcells in there. Then type A to select everything, and then say, let's see, what's the command? Do I have one here? I've forgotten the command, but yeah, there's I think it's select. It's not coming to me in the moment, but yes, it can be done.
Okay, so
select save. That's it. Select save, and then give it the name of the cell.
Select save.
Yeah. Now, one thing to mention about that is that it doesn't replace the existing paint and cells and so forth. So I've created now a new cell called XXX. And if I go up here and say get cell XXX, it just instantiated a version of it, but it didn't replace the stuff that I selected with it. So I would then have to, if I wanted to replace it, I would have to delete that.
So now, how
Bring
can
that
I
down.
flatten this cell back? I mean, I want to flatten it out. I don't want to be in a cell anymore. I want to flatten the devices inside the cell.
You can, well, for one thing, you can, again, the cell exists, so.
Yeah, I want the devices
Oh,
back.
right, I know, but the cell exists, so the cell is going to stay there. If you want to completely remove the cell, that's a different problem. But if you just want to flatten what's in it, you can do this, which is, again, to go Control. That gets rid of the whole cell. Is to, sorry, I have a little trouble with the line keys that we chose. Select everything in it, and for instance, C for copy. All right, now I've just copied not the cell itself, but everything in it. So this is still down here. This is still a cell. Actually, that wasn't a cell because, but I've just taken all that paint and made a copy of it in a flattened sense.
Yes. Mm-hmm.
So does that answer your question?
Yes. Okay. Can I make a relative copy of a rectangle? I mean, if I'm going to make an array of a resistor and I want to connect them all, it is really not practical to connect each one by my hand. So I think we could do something like copy some sort of rectangle metal in a relative way. I mean, a relative distance from the metal that I have already, so that I can do 100 or any kind of number of this kind of small metal along the way to all the resistors to connect them at one click.
Mm-hmm. Right. So there are two things I can do. One is to say, while I have a selection, is to say array 110. So you see what I did. I had the selection, and the top of the box determined the pitch of the array.
Yes.
Likewise, I can do the same thing here, is to paint a bit of metal, put the box to the pitch in X and Y that I want, and say array 4, whoops, I have to select it first. And then say array 4, and it makes the array of metal. There's an additional one too that you can use, which is to select the paint and then say copy north 2 microns, or copy north, say 4 microns, and you can use the up arrow on the keypad to bring back the last command, so you can just keep doing that. Obviously, the array is a more efficient way to do it all at one go.
Mm-hmm. Yeah, I think I'm done with all the questions I have here, at least for this webinar.
Yeah, and if you have more, just ask, and there are additional commands that you can find on both the Magic web page on Open Circuit Design and a series of tutorials you can go through. If you do the tutorials, bear in mind that they have a different set of key bindings. Here we've tried to make the key bindings fairly close to Cadence so that people who come into this environment from Cadence don't feel completely lost by it.
Mm-hmm. Can we make it the background with another color, like a black background or things like that?
That's very hard. I mean, it can be done. It requires a lot of manipulation of color maps and things, and
no need for that.
I think you'd better. I would prefer that you just try to get used to the gray background.
Okay.
I think if you use it enough, you'll find that the gray background is actually a lot better to work with. I find that the black background and Cadence and other tools just is very bad for eye strain.
Yeah, that's good. Okay, that's all the questions I have. Thank you.
All right. Are there any other questions? If not, then we will declare this webinar at an end. And thank you very much for coming. And I hope you learned a lot. And as I said, on next week, I will continue on to showing you how to do LVS and to extract for simulation.
Are you sorry? Are you going to upload this? When are you going to upload this webinar? Because it
every
contains lots of-
webinar we do does get uploaded. We usually go through it and do a few edits just to remove out blank spaces and things. But it should go up onto the website within a day or two.
Yeah, as
Could be
soon as
today.
possible, because this is
Will be
useful.
tomorrow.
This is the
Oh
one
yes,
useful.
yeah, absolutely. We understand that only a few people can make it to the webinar, and that it needs to go up on the website so that it can be viewed by
And
everyone.
also, this is the weekend, so we want to work at the weekend. So this webinar would help us a lot in working on the layout. So it would be possible, good or better to upload it before the weekend ends. Yeah.
Sure, Ibrahim, I'll do that.
That's good. Yeah, thank you very much.
Okay, then that concludes the webinar, and thank you all for coming.
Okay, thank you, everyone.
Thank you. Thank you,
See
Tim.
you next week. Thank you.
See you. Thank you.
Bye.